Hello, everyone. Thank you very much for being here with me today at NDC Sydney. I'm really looking forward to presenting to you from horror story to fairy tale, writing code that people want to read. I am happy to take questions throughout the presentation. Feel free to either unmute yourself and chime in or to leave comments in the Room 4 channel in Slack. I'll be monitoring that as well if you have any questions or comments throughout the session. And there are a few places that I'll be looking for interaction, so please feel free to interrupt at any point, and I look forward to talking with you. So when we are building software, we have some goals, some design goals, and I'm happy to listen to any goals that you have when you're writing software. There's a few things that I've come up with, some implicit goals that we have. First one I came up with is that the program does what it is supposed to do, right? That's an important goal when we're building software. And it's something that we always have, but don't necessarily write down anywhere. It's kind of an implied thing. Are there other implied design goals you can think of that we have when we are building and designing software? Perhaps there's no bugs. Perhaps there are no security vulnerabilities, and feel free to type them in Slack or just chime in. The software should be easy to use, right? That's a goal we commonly have when we're building software. And another one that is often a goal, but not something that's necessarily codified, is that the code should be easy to modify as the requirements change. We want to be able to continue to develop on the software over time. We want it to be able to grow and adapt and change. And there's a lot of things that we do to kind of build this into our processes, but we don't always identify this as a stated, clearly defined goal of our projects, but it's often there in the background. So with these goals in mind, these implicit goals in mind, let's talk about the act of writing software. So where do you spend your time as a developer? What are things that you spend time on? Some of the activities that you do may include typing code, actually physically entering code into the system. What are some other things you do? You may do brainstorming or spend time problem solving, working things out in your head or on a whiteboard or whatever that may look like. One of the top answers I get to this question is, of course, meetings. We spend a lot of time interacting in whether it's a virtual meeting or an in-person meeting. We spend a lot of time talking with each other, hashing things out. One type of thing that we do is testing. We write unit tests, maybe we do manual testing, integration tests, whatever type of testing we're doing, we do a lot of it. And sometimes we spend more time writing code for tests than we spend writing the code that we're testing. Documentation, right? Not all the writing we do is code. Some of the code, the writing we do is just documentation or plain English, whether it's technical documentation or user documentation. That's another thing we may do in part of our role as a software developer. So all of these things have something in common, and that is we spend a lot of time reading code. We have to understand the code that has been written, whether it was written by us or someone else. So we spend a lot of time reading code. In fact, from the book Clean Code, the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. Therefore, making code easier to read makes it easier to write. Another quote, this is known as Eagleson's Law. It's unattributed. Any code of your own that you haven't looked at for 6 or more months might as well have been written by somebody else. And I've actually seen a number of people claim that that's probably as short as 8 or 10 weeks. When we put something out of our head for just a few weeks, when we come back to it, we've got to pick it back up again. It's no longer in our working memory. It's no longer ready. We've got to go back through the effort of figuring it out. Therefore, it might as well have been written by somebody else. Another quote that I love about this concept of reading code from Martin Fowler. Any fool can write good can write code that a computer can understand, but good programmers write code that humans can understand. And this brings me to an important concept about code. And when we think about the activities that we do as programmers, in fact, let's go back to that list really quickly. Only one of these involves writing code, but all of them involve reading code, right? And because of this, code perhaps doesn't exist to tell the computer what to do. That is not its primary function. Its primary function is perhaps to serve as documentation and communication to other developers. Yes, it needs to do what we set out for it to do, but it spends most of its time, most of the life of the code we write is spent as communication to people, not necessarily to the machine. It's an important perspective for us to have when we think about how we're going to write code. So a quick introduction of myself. I have been working as a software developer for more than 20 years, and I have worked for a number of different startups and companies. I have definitely written some horror story code in the past. And we're going to look a little bit at some horror story code, look at code that was written just for the machine, and then look at ways that we can process this. So here is a code example of bad code that I pulled from the Daily WTF, which is a great fail blog website for developers. And I challenge you to tell me in 2 minutes what this does. It's very interesting to look at. What is it doing? Let's look at the first line. You are converting a fixed time string to a date time object, and then back to a string, and then back to a date time object, and then back to a string. Wait, except that's datetime.now. So now we have the current time as a string, and this other thing as a string, and we're doing all this manipulation. And this code, the way it is written, takes time to figure out. And when we get all the way down to the bottom, we're saying if x is greater than 10. Wait, hold up. Where does x come from? If we look that it's on a split, it's a split of a result. We're subtracting the two dates. We're splitting them. My guess is that's returning true if there's 10 or more days, or there's more than 10 days between today and the other date, but I'm not 100% sure. I'd have to really dig into that. It's not immediately obvious. The naming of the variables does not help us. There are no comments to help us. There is an assumption that we're going to be able to understand this. There's no context as to why we're doing it, right? At the end of the day, we're bringing in dates and returning a Boolean, true or false. So one thing that we can do to make code easier to read is potentially to have more descriptive variable names. So let's look at this example. Very long variable names. Inventory integration direction dot do the same change in shop. Calling a function, do the same change as shop. What does that mean? Do the same change in shop. Do the same change as what? Same as what? If we use a word like same, it indicates that we are comparing something, that we're doing something in relation to another thing, but there's no other thing here for us to compare with. The same as what? Get changed data from inventory. Okay, so the data is changed. It's changed based upon a sync date, but then what am I doing with it? The only verb here is do. And so maybe if I was working on this software and I had all the context of this piece of software in my head, this might possibly make sense to me, but it's certainly not going to make sense to a brand new developer starting on this project. They're going to have no idea what this means. So even though we have used long variable names, descriptive variable names with all these things in it, it doesn't help because the specific language we've used is not helpful. So now instead of something that is short and confusing, we have something that is verbose and confusing, and that's not helpful. Last example, another example from Daily WTF. What does this do? Does it return true or false at the bottom if everything's successful? It takes us time to process this, and there's a few reasons why. First, we're starting by setting something to false, that we're or equaling it to something else, which means the previous value or the next value. And then, but we're ORing it to the negation of the return of another thing. Update file stir template. Presumably that might return true if it's successful. And then at the bottom, we're negating that result, but the name of the variable is also a not. So here's what's going on. We have lots and lots of negations. We have 1, 2, 3, 4. What do we have? 10 negations in here, 12 negations. Negations are actually really hard to read. Negatives take time because we always kind of in our head convert those negatives to positives in order to understand the thing that's actually happening. And so when we write code like this, sure, this may be really elegant. It may work really, really well, but it takes time to process and understand, okay, is this going to return true or false at the end when it's successful? So there are ways that we can write code to make this easier to read without necessarily making it any longer or more verbose. So we need to think about those things when we're looking at code and understand that the more straightforward the code is, the easier it is going to be to read. So why do we care? I've shown you some examples of bad code, potentially, but is it really that big of a deal? Like, if I ran out that code, I would be able to figure out what it did. I'd be able to make my changes. I'd be able to move along my life. So why do I care about writing more readable code? And one of those reasons is that there is confusion. Code is a form of communication. When there's confusion in our communication, it's hard to know what's going on. I'm going to read a quick quote from SpaceX. Excessive use of made-up acronyms is a significant impediment to communication, and keeping communication good as we grow is incredibly important. Individually, a few acronyms here or there may not seem so bad, but if 1,000 people are making these up over time, the result will be a huge glossary that we have to issue to new employees. No one can actually remember all these acronyms, and people don't want to seem dumb in a meeting, so they just sit there in ignorance. And this is particularly tough on new employees. So this is a great example of why acronyms may be bad or harmful, because they don't necessarily mean anything to us until we've learned this, essentially learned a brand new language. But this applies actually to anything where the language that we're using isn't going to be immediately obvious to somebody that is new to the team or the project, whether it's an acronym or not. So anytime we are using communication in a way that is confusing to newcomers, we have created a problem in our organization that we're going to have to overcome. One reason that is a problem is because we are always onboarding people to our teams. Even small teams, even well-established teams, we tend to onboard people fairly regularly. That might be because many developers switch jobs every 2 years, 2 to 4 years. It could be because we're hiring outside contractors to expand our resources to work on specific parts of our projects. It could be because our teams are growing. Whatever the reason, anytime we bring somebody new onto our team, if we have introduced confusion, it is harder for them to get up and running, harder for them to be able to contribute value to our project. That looks bad on them, but it's also bad for us because now those of us that are still there are having to work extra hard to make up that difference. Another reason that this is important is for inclusivity. Not everybody has the exact same background as a developer. Some developers come from computer science degrees. They have a master's in computer science. They maybe worked at Google, Microsoft, or Facebook, and that is their background. We may have other developers that they graduated high school, went to a coding academy, and started coding. And both of those backgrounds are perfectly valid. But that means you have a different common language to use when you're working on things. And it means that different people have different access to, or have gone through different educational paths when learning to code. And therefore, the way we write our code is going to be more easily understood by some developers than others. So we need to think about this. Are we inadvertently creating barriers to entry for future developers based upon the way we build our code when we think about our code as communication to future developers? It's very important. Accessibility. Clean code, semantic code, especially things that are UI related like HTML, is a very important part of it, an accessibility implementation. But it's also important to remember that the developers you work with may also have need for accessibility tools. Maybe the developers you are working with need to be able to customize their IDE with different colors because they have color deficiency. They don't see colors the same way you do. They may have other disabilities that make it harder for them to do certain things than others. And if we have written code in a way that is not easily approached through accessibility tools, we've made it harder for those people to work on our projects. And that is a huge problem. We don't want to do that. Another reason to write clean, approachable, easily understood, easy to read code is that it's easier to avoid bugs. The more straightforward our code is, the easier it is to identify bugs, to avoid them in the first place, and often this makes the code more testable. Again, when it's easy to write tests, when it's easy, when accessibility is easy, automation is easier. Consistency helps us build automation and maybe save ourselves time through document conversion, code generation, text parsing, linting, all these types of things. These are all examples of automation that help us as developers to make our lives easier. Another thing that factors into code as a communication is going to be naming. It's just one small aspect of code readability, but it is a fairly important one, and it's a fairly challenging one. In fact, this is an old quote from Phil Carlton, who was working on Netscape Navigator at the time, I believe. There are only two hard things in computer science: cache invalidation, a known hard problem, and naming things. So coming up with good, meaningful names, Phil was saying, is just as hard as some of the hardest problems in computer science. It is a challenge, but it is a challenge that is worth our time and effort in just the same way that solving the hard problems are. When we talk about names, what are things that make naming or word choice good or bad? How do we kind of decide what this is? One of the challenges that comes up is ambiguity. And ambiguity, of course, refers to any word or phrase for which a single cohesive concept cannot be identified, at least without some additional context. So using an example in spoken English, what if I say there, or there? What do I mean? Well, there's three different words that I could mean when I say that. What about to, or two? Three more possible things that I could mean. They all have slightly different meanings, very different meanings, in fact. And so we don't know when I say to without the rest of the sentence around it, what do I mean? So this is an example of ambiguity, and we have written ambiguity as well. There are plenty of examples in English, for example, that when you write something, it may look the same way, but then sound different, but it means two different things, and we need additional context to understand what we're talking about. When I say free, what do I mean? What about when I say software is free? Do I mean free as in popcorn, or do I mean free as in free to use however I want? Free as in freedom, or free as in free of cost? There are always different nuances to the words, and if that nuance matters, if that difference in understanding matters, then we need to provide enough context to allow the reader to make the right decision, because this is ambiguous. Ambiguity comes up a lot in acronyms and abbreviations, but also acronyms and abbreviations are not always necessarily universally understood. So here are a few acronyms, abbreviations, and initialisms that I've run across as a software developer that people don't necessarily agree on. In my humble opinion, or in my honest opinion, I've seen people legitimately get angry with each other for not agreeing on this, which is, it's close enough, right? We understand, it's in my humble or honest opinion, but there's no consensus on which one it actually is. Content management system. I once worked on a content management system named .cms for Centers for Medicare and Medicaid Services here in the US, also CMS. So I had CMS for CMS with CMS. CMS was flying all over the place. Nobody had any idea what we were talking about. It was great. All types of different examples where we may or may not know exactly what we mean when we see this out of context. RAM could be memory. It could be an animal. Do we have the context? Is it all uppercase? Is it mixed case? My personal favorite, though, is ST. This can mean stanza, but it can also mean street, straight, saint, Star Trek. The Wikipedia page, the disambiguation page for ST, has, I think, 34 entries for ST, and half of them are related to addresses, which means that even knowing that ST is being used in the context of an address doesn't tell me enough to know for sure what word it is that it's being substituted for. So acronyms and abbreviations can be really harmful for actually communicating the full intent of what we're saying. But enough about the horror story. Let's get into the fairy tale. I've talked about ambiguity. I've shown examples of code that is hard to read. I've hopefully explained why this is important. Now let's look at some ways that we can approach solving these problems. And the first thing we need to be able to do is assess whether or not the code we're writing is easy to read or not. How do I know? How do I know if this is good or bad? So one thing we can look at is semantics. So semantics is the branch of linguistics and logic concerned with meaning. In code, this refers to choosing the right words and structures to convey that intended meaning. So for example, if I use process user, that is not very semantically meaningful. It just tells me that I'm doing something. It could just as easily say do stuff. Doesn't mean anything. But login user, login means something. It's telling me what's happening with that user. In HTML, for example, if I use a div tag, it doesn't give me any context or meaning related to what's going to be contained by that tag. But if I use a nav tag, now I know that this is wrapping navigation. And this is really important that we use this correctly, because this is a perfect example of accessibility in action. By making the right choice, we help assistive technologies communicate more effectively to the user what's going on. If we choose the div instead, we're not providing enough context or meaning for somebody to understand what's actually happening here. So that additional semantic is really important. So one lens we can use to review our code is semantics. Another way to review our meaning is the vocabulary. So words that are used are only particularly meaningful if they exist within the vocabulary of those who are reading them in the future. Okay, so if you go back and you read something that was written 100 years ago, you're going to have a lot harder time understanding it than if you read something that was read yesterday. Why? Because language changes over time. And that's normal, but we still need to be really careful that we don't add additional complexity where it doesn't need to be. So let's look at some vocabulary examples. And these are examples of ambiguity as well. Reciprocal. What does reciprocal mean? In mathematics, it can mean the inverse. It can mean the opposite. In relationships, it could mean reciprocity. If I do something for you, you do something for me. But those meanings depend upon us sharing the same frame of reference. If we both know that we're having a conversation about mathematics, that's fine. We know what reciprocal means in that situation. But if we know we're talking about relationships, then we know what we're meaning. But if we don't know what the context is, then reciprocal may be confusing. Another one, great example is ray. If I say ray, what do I mean? Do you know? Is there enough information? What's the context? Are we talking about mathematics, where it's a point with a line that extends in one direction? Or are we talking about zoology, where it is an animal that kind of swims through the ocean? Or perhaps I'm talking about a ray of sunlight. So it's important that if we share a common specific vocabulary, if I know, for example, that I'm talking about mathematics, then I can use these words with confidence, knowing that future readers are going to understand this context. But if the context itself is ambiguous, then I need to provide that additional context so that they understand how to process that word in the place that I've used it. One of the things that I've run into in software is that sometimes different industries use similar words to mean slightly different things, or even sometimes very different things. Insurance and banking, for example, they use a lot of the same financial terms, but they may define them in subtly different ways, and that those subtle differences are extremely important when we're building software where we have to be perfectly precise. So it's important that we are clear in exactly what the definition of those terms is within the context of our projects. Failing to follow the vocabulary of your industry can also be very expensive. One company that I worked for was actually an insurance company. Insurance, at least in the US, has very clearly defined terminology. As an industry standard, there are specific definitions of things that are useful for building integrations between organizations. Well, the company I was working for didn't really do that very well. So instead of converting their platforms to use this common language, they built custom integrations to every single product, service, and tool that they needed to integrate with because they weren't doing things the way everybody else was. That choice to have their own vocabulary became very expensive over time. Another thing to use to kind of determine if what we're writing is clear or not is to look at intent. Can I look at this code? Can I read it and understand the intent of the author? Do I understand when I should use the same bit of code in the things that I write? So a function name such as convert time, I don't necessarily know when I might want to call that to convert time. What's the context here? When do I use this? Why is it being used here in the code? I don't know for sure. But if I instead indicate the intent in the name of the function, local to UTC, for example, I understand that I am converting that date from a local time zone to a UTC time zone. Now I understand what it's doing and when I would use it. Another example, check username. Well, check it for what? Am I checking to see if it's already taken? If I'm checking to see if it's logged in, am I checking to see, what am I checking? Is it valid? Am I checking it against the dirty words list? What am I doing with this thing? So if I instead provide that intent in the name, is username available? Now I can read that code and immediately understand why it's being used here and when I might also want to use it. Disambiguation. So I spoke earlier about ambiguity, and ambiguity is a big part of confusion in language. So let's look at how to disambiguate things. So for example, execute can mean a few different things: run a process or kill something. So maybe we should use run or kill instead to be really clear about what we meant. Light. Does this mean bright or not heavy? Not dark or not heavy, right? I could use bright. I could use, I don't know, light as in weight. I can use a weight variable to indicate the heaviness of something. I can use heaviness as a rating. So a lot of different things that I can do to make it clear the context of what I mean when I use the word light. Ephemeral use. One thing that happens a lot, ephemeral means temporary or for a limited time. And a lot of the code that we write is temporary. It's a fundamental component of agile development, which many of us use agile methodologies, right? And we know that the code we write is going to be there temporary. We have this habit sometimes as software developers to, for example, implement a quick fix that we are going to come back and fix later, and then it sticks around for a really, really long time. I'm sure that I've run into this a lot. I'm sure you have too. And then in some environments, like in a corporate environment, you may end up with stuff that sticks around for a really, really long time that was intended to be temporary. In a startup environment, sometimes you have the opposite. You write things thinking it's going to be there forever, and then you discover you have to rewrite it again 3 months later, whatever. Point is that we need to be really cautious about the longevity of the thing we're writing and how long the communication will be valid for. Here's an example, silly example from XKCD. This function is valid exactly once. The first time we call it, it's a random number. The second time we call it, it is not. This is a ridiculously extreme example of ephemeral code in that it is useful exactly once, but it illustrates the point, right? We need to make sure that when we implement something, we can certainly, it has utility beyond the first time we call it, the first time we use it. Here's another example. This is a visual example using CSS and web design. You have been working on the user interface for a website. Their marketing team gave you the branding colors. Here is what you put together with those colors. Fast forward a few months and they tell you, hey, we really want to change the color palette to this here. You're like, fine, no big deal. I'll go in and plug in a few variables. Update the thing, we're done. Easy peasy. But there's a problem. That's the problem. So we have a .orange class to represent orange, but we have a .blue class to represent yellow and a .green class to represent purple. What in the world happened? Well, what happened is that when we originally set up these color palettes, blue did represent blue and green did represent green. And then we used those class names all over the HTML to specify things, what colors we wanted things to be. And then when the time came to make that change, it was really, really easy to change the hex code definition in the one place on that CSS class, but it was prohibitive to change the name of the class everywhere it was being used. So we didn't bother. And this is something that I see a lot. And the solution here is, of course, that maybe we should have used names like primary color, secondary color, tertiary color, and then we can use those everywhere freely without giving an indication that it's going to be blue necessarily. Another quick CSS example, and this is a situation where when we want to refactor something, we have to be really careful about how it's being used, and we need to make sure that we write code in a way that it can be refactored. Like I said at the beginning of the talk, one of the implicit design goals of most software is that it's easy to modify over time, right? So here's an example, another example I've seen a lot. We have a CSS class called write. And in this particular implementation, it has been implemented as text-align write. And one interesting thing I've seen in CSS frameworks over time, over the years, I've seen most of the CSS frameworks have some class like this implemented right, but 50% of them implement it like this, and the other 50% implement it as float right. So just because I see this doesn't necessarily mean I know how it's going to be used. But let's continue. So I have these numeric columns and I want them to be right justified because that's how I want to present numbers. And I use my class right because it does what I want it to do. And I'm reusing code. And so I'm following the rules of code reuse. And this is fantastic. And then later on, I have this other numeric value that I want right justified. It's the counter for how many characters have been typed into a comment field. And everything's fine. But then there's a requirement to change the way that counter looks. So I implement the change right there in the class because it's there, and now it looks like this, and I have no problems. It looks good, it gets passed, it gets merged, and then somebody starts complaining, hey, why do my columns of tabular data look bad? They're not supposed to look like this. Well, I didn't see that because I didn't test every single place in the application when I made that little CSS change, and now we have a problem. I could have avoided this problem very easily by using a more specific semantically meaningful name, numeric column. And now if I need to change anything else about numeric columns, I can do that right here. And then this other thing, this could have been a character counter. And then I could have changed it over time. And the lesson here is that just because a function, a class, has the exact same implementation, has the exact same text, the same bit of code inside of it, does not mean that it is the same code. So when we started, we had this class of write that used text-align write, and we reused it to avoid typing text-align write a second time, but that was a mistake. That wasn't a good example of code reuse because we were using it for completely different contexts, completely different scenarios, completely different purposes. And that means that when the meaning diverged, because they meant different things in the first place, as that code starts to diverge, now we have to do work to separate those meanings instead of continuing to use that same thing. We can't reuse that. So we need to be careful when we're trying to reuse code that we don't inadvertently reuse code that has a very different purpose and will have a very different future trajectory. So one of the rules that I use in writing code is the rule of 3. If I have to use something 3 times before I try to find a way to reuse it. And it has to have the exact same purpose, has to have the same meaning, the same intent. If it doesn't share an intent, I don't care if the code is the same. I'm not going to give it the same name. I'm not going to call the same function. I'm going to create a duplicate with a different name with its own intent and meaning. So here's an example of refactoring potentially gone poorly. So what can happen when we come up with rules for what good, clean code should look like, and we implement them in a linter, and we prevent people from committing to the repository if the rules aren't followed? What we end up with maybe is a situation where, let's say that this was a 1,200 line function, and we implemented this rule where a function can be no longer than 500 lines. And that sounds great because we know that shorter functions are easier to read. But then somebody comes in here and they're like, well, I'm in a hurry, because we always are, right? I'm going to break this into 3 separate functions, just call them in order and move on with my life. And I haven't made anything easier to read. I haven't made anything easier to understand. I've actually added a whole new layer of misdirection to this function just to satisfy a rule. So I need to be really careful in avoiding a situation where we're encouraging bad refactors just to follow rules. So one thing that can sometimes come up and bite us when we're writing code is spelling. And this is a tough one, because I don't ever want to make fun of somebody or pick on somebody for spelling. It's harder for some people than others, and we don't all speak the same language natively. Okay, and so this is a sticky point. But the challenge here is that when we're trying to modify or refactor code over time, when we are trying to find, for example, every place that expiration is used so we can make a code change related to that, if there are misspellings, such as the ones in this example, that's very hard to do, because most of our tools do not do a very good job of providing alternate spellings of the code we're searching for, which means if there is a typo, we simply won't find it. Just the same as typos, though, if we use abbreviations sometimes and use the full word in other times, those are 2 different things I'm going to have to search for now to find it, and I have to know that that is the search I need to perform. So trying to refactor code in the future when we are inconsistent with how we write things can be really challenging. And one thing you can use as an indication if your code being fairy tale code is that as you start to build things, the implementation strategies are fairly straightforward. If they're not, if you find yourself writing really convoluted code or jumping through a lot of hoops in your code that are really hard to follow, a lot of times that's actually a sign of a poor architecture. Maybe you need a different data model. Maybe you need a different algorithm. Maybe you need a different structure to your code to make it easier to share the things you need to share or to process the data the way you need to process it. So I like to look at confusing code not just as a, hey, this is bad code and it needs to be fixed, but maybe there's actually this is a symptom of an underlying problem that we need to address instead. And here's an example of this. So when we see chaos and confusion in our code, it may be a sign of an underlying problem. In this particular case, the first thing we notice right away, we have a string one, an S1 and S2 variable that are both strings, and they're being reassigned to each other repeatedly. Well, it's pretty easy for us to look at that and realize that that could have just been one variable for starters all the way down. In fact, we didn't even necessarily need the variable, because looking at that, it's very obvious that we could have just chained dot replaces together in a line. So we didn't even need the variables in the first place. So we've added complexity here. And these variable names, S1 and S2, first of all, they're not descriptive. And second of all, the way they're being used is redundant. So we can look at this and immediately say, okay, the person that wrote this may not fully understand how that replace method works. Maybe they don't understand how the string assignments work. Maybe something else. But it's worth asking that question at that point. How can we simplify this? And the really interesting thing is that what's really dangerous here is if you look at that, we have an sw.write s2 at the bottom. If we look at that particular line of code near the bottom, if I were to use S1 instead of S2 there, it might not work. So if I add an additional dot replace to the string of dot replaces, it may not get picked up correctly. Maybe that last change doesn't get written because now it's assigned to the other variable, and that can be a source of bugs. So using these redundant variable names actually can easily make this code hard to fix, hard to improve or add on to, can introduce pretty subtle bugs in the future just because we used a variable name we didn't need to. So getting to this point, we want fairy tale code. We've talked about some strategies for doing that, but let's make this more concrete, more applicable. I'm going to give you a checklist for some things that I do to help me ensure that I am producing good code that is easy for other developers to read. And to be blunt, the person that probably benefits from this the most is future me. When I write code that's easy to read, when I come back to it later, I benefit from that. So the first thing to consider is your audience. The very next person to touch this code is most likely a developer who did not have the requirements or conversations you just had in their head. Maybe they didn't have those conversations at all. They certainly don't have that context in their head right now. So if you went off and had a few conversations with people, then you sat down and you wrote this code, they don't have all that context when they come back and look at it later. And this, again, this could be future you. So anything that was confusing or difficult or required external conversations or required you to look up documentation in order to figure out how to write this, that should be passed along to the next developer with as much context as possible. So again, the future audience does not have access to all your external context, but they are busy and distracted. We always are. When we're writing software, a lot of times we're in a hurry. We have a long list of things we're trying to do, and we're trying to do it quickly and easily. So let's make this as easy for us to do as possible. We need to use specific language. Names, for example, should be specific and written in the common language of your problem domain. Do you work for an insurance company? Great. Use that common language. Do you work for a dentist? Perfect. Use that terminology. You can, in general, assume a certain level of technology specific language as well. But if you're going to deviate too far out of your core industry, then it's really important that you clarify that. So when we talk about specific names, provide context and clues to what something means. So in this particular example, tax. Well, what do I mean when I say tax? There's so many different types of taxes. And the tax, is that tax a number? Is that a specific amount of currency? Or is it a rate? In other words, a percentage that I have to multiply some other value to find the actual tax amount. I don't know from looking at just the word tax. So I can provide that additional context. I can be more specific. So sales tax rate tells me that this is going to help me calculate the sales tax. And in order to do that, I'm going to multiply this by the total value and produce the actual sales tax amount. I know that just from looking at that variable name. Item order quantity. It's not just QTY, it's the quantity of items in an order. Perfect. I know I have context now. I understand what that means. Actions. Function and method names should include a verb. Names like this are very bad because they don't tell us what we're actually doing. We know that functions are actions. We know an action is being performed. So I know that an action is being performed to the sales tax or an action is being performed by the order quantity, but I don't know what that action is. That means that when I see this in code, I have to drill into that function and read the code related to that function implementation to actually understand what's going on. Or I could provide a more appropriate name, which includes the verb, the action being performed, so that I have that context just from looking at the call without having to actually look at the implementation of the function itself. So calculate sales tax tells me that I'm calculating sales tax, and presumably by the variables that I pass in now, I'll understand how that calculation is being performed. Fetch order quantity, that tells me I'm retrieving something probably from a database or other data store. Use full words, use abbreviations sparingly, and when you use abbreviations, there should be no confusion as to what it means. Stats, probably actually an okay one, but whatever you choose, be consistent. If you're going to use a specific abbreviation, always use that abbreviation. Don't use the abbreviation sometimes and the full word sometimes. Don't create creative misspellings of existing words. So this is something I've seen in Java a lot. The word class is a reserved word. It's a reserved word in almost every programming languages I've ever used. What I see in a lot of libraries then is that people will come up with creative ways to come up with a way to spell this that is not a reserved word. So CLAZZ or KLASS, class and class. And realistically, there's no point in that. It could just easily be class name, right? Or class instance if you're passing an object. Or perhaps it could be the CSS class or the CSS class names. If it's an array of multiple things, it could be classes. There's so many ways that we could do this that were meaningful without creating a misspelling. And it's really important that we use full words as much as possible so that everybody automatically knows how to search for them. When we sometimes use abbreviations and sometimes don't, we create this kind of guess method to finding bits of code that we need when we're trying to solve a problem. Because a lot of times what happens, at least in my experience, when I get a story to work on some code and it's related to a specific concept, one of the first things I'm going to do is search through the code base for the keyword related to that concept and see what's out there. And if we've not used full words, I'm not going to get results. Related to that, spelling. Most editors support spell checks at this point in time. I use VS Code. I do use a spell check in there. Spell check is a great resource to just help make sure that we have made our code easy to search, and that it is one reason that spelling matters also, as well as full words, is that if we are working with somebody that uses a screen reader to understand the code or other assistive technology, it will actually make sense instead of just being an amalgamation of letters that have to get spelled out. And spelling sometimes can be kind of interesting. So refer actually has 2 R's, but in the original HTTP specification, it had just 1 R in the specification, and therefore we've ended up with this misspelling being implemented in basically every single web browser and web server ever, because it made it all the way into the specification like that. And that just, it creates a challenge for people who are trying to work with that. So we need to make sure, and that create versus create, that's another one that's in the C library. Use the full word correctly spelled, and we will save ourselves headache down the road. Comments. This is a big one, right? Comments are really important. One of the things that I've said a few times is that we need to provide context. Comments are a great way to provide additional context in our code of what's going on, why we approach something a specific way. But we don't want comments like this. I can look at the code and tell you that it's iterating over a list of items, right? So comments should explain why or how, not what's happening. So for example, here I am calculating the sum of quantity and price for each item. And then for verification per CR123. That's not just repeating the code, that's telling me something valuable. And maybe I don't need that calculate sum of quantity and price. Maybe that's totally redundant because it's obvious in the code, but it might not be. If I'm just passing a bunch of objects into a function and I don't get to see which properties are being extracted, it might not be obvious there. So I need to consider carefully how much comment do I need to be meaningful without being too verbose. How comments can be useful when auto-generating documentation from your comments. Whenever you need to say, I had a conversation with so-and-so about this thing and we made this decision because of XYZ, provide that. We decided to implement this way because of this specific factor. Put that in a comment, because in the future, the next person to come in there, they will avoid doing a damaging or a harmful refactor without carefully considering that reason that you had when you wrote the code the way you did. One thing that you can use to provide context as well as comments is namespacing. Business state. Here in the US, state could mean things like California or Florida, but it could also mean open, closed, operating, not operating, right? We don't necessarily understand what that means for a business state. So business.address.state tells me that that state is related to the address of the business. It's a location. Total by itself doesn't tell me anything, but order.total does. So namespacing or object context is one way that we can provide the additional information that we need to understand what the code is doing. Take advantage of that. That avoids duplication and redundancy. I don't need to say business.address state or business.address business state. That's redundant. I don't need that. Namespacing is great. And one of the best ways, in my experience, to make some of these improvements in your code and on your team is to put together a checklist of specific things that you as a team want to do. Come up with a handful of guidelines. Come up with team agreements. And this can be related to naming. This can be related to just general approach to code, how you're going to do your code reviews, and then work through those checklists together in the code review. And however you do code reviews, you should definitely have a kind of it doesn't have to be super formal, but you should have a process that you follow consistently. Make this checklist part of your code reviews. And the reason I like to use code reviews instead of hard and fast rules in like a linter, for example, is if the linter starts failing or produces warnings, then that is going to cause a situation where you're encouraging your developers to do things that could be potentially harmful or problematic just to get the linter to pass. Or you may be teaching them to just kind of ignore warnings because there's so many warnings that they just start ignoring them, and that's bad as well. But in a code review, we can implement changes in code that would normally fail everything, and we can slowly, as we address the code, work together to make improvements that we agree on. And they don't have to be hard and fast rules. We can decide together that, hey, this code, in this situation, this rule just doesn't make sense. Let's not apply the rule in this situation. And you can agree to that. And maybe you can change your team agreements accordingly. But remember, code reviews are not exist to remind everyone how smart you are. They are not there to make other people feel bad. The purpose of code reviews is to apply consistency on your team, to apply consistency to code, and it's a great resource for mentorship. But in my team, I apply this as a mentorship, not just from senior developers to junior developers, but the other way around, because newer developers giving you comments and feedback on your code are going to help you produce more readable code because they're going to point out right away the things that are confusing. And if it's confusing to them, it's going to be confusing to other people as well. And it's going to help you write more approachable code that is easier for new developers and new people to your team to pick up and read very easily. So we want to live, of course, happily ever after. This is fairy tale code after all. So quick summary. Code is a form of communication between developers. That is how it spends most of its life. Communication, including code as communication, should be clear, succinct, and specific. We want to convey meaning and intent with the language we use. Readable code in its very existence. By making our code readable, we support inclusivity, accessibility, and also the company's bottom line, because we make it easier for new developers to get up and running. We make it easier to avoid bugs. We make it quicker and cheaper to make changes and fixes to the code. So it really does help the bottom line as well. And the one great way to do this is to create team agreements together about how we're going to approach this code, and then support that through code reviews. So I want to thank you very much for your time and attention today. I'm happy to answer any questions. We have just a couple minutes, and I will follow up in Slack later as well if you want to hit me up in there. And feel free to follow me on Twitter as well. But thank you so much.